Hi everyone, welcome back to Physics 11. So in this video I wanted to go over a couple of homework questions that somebody asked. So again, this is section 8.2, current, Ohm's law, and power. So question number 8 says when an electric appliance is connected to 120 volt power line, there is a current through the appliance of 18.3 amps. What is its resistance? So that's really very high current through an appliance. So maybe it's something like some sort of heater or something like that uses a lot of current. But anyway, part A is asking you what's the resistance. So you can use the Ohm's law, V equals IR, solid for R, and find the resistance. The one thing I changed here, I added a decimal to keep the same number of sig figs as in the answer here to have 3 sig figs. Now part B says what is the average amount of energy given to each electron by the power line. Now this is something I haven't talked about yet, and it's probably a good place to talk about it now. So there's one definition we haven't mentioned. It's called the electron volt, which is a measure of energy on quantum level, on basically particle physics level. So whenever you deal with tiny particles, you don't really use joules, you use electron volt. So what does electron volt mean? Well, this is the amount of kinetic energy that one electron gains or loses as it goes through 1 volt potential difference. So potential difference is the voltage. So that means that 1 EV, or electron volt, equals to 1.6 times 10 to negative 19 joules. So remember, the charge per electron is 1.6 times 10 to negative 19 coulomb. So it's the same amount, but now we're just talking about joules per coulomb. So that's how you have to solve this part B. Otherwise, you can't really do the question. So that's one thing I haven't talked about, so it's a good place to talk about it, because this is the amount of energy that one single electron will gain as it goes to 1 volt potential difference. So if you have 120 volt potential difference, like we do in this question, that means that you take your 120 volts. Now you want to have energy, so you have to basically convert our EVs to joules here. Now we want to get rid of the voltages, so we have to have volts on the bottom. In this case, the EV stands for one single electron, but these are still volts, so EV is going to go on the bottom, the joule is going to go on the top. So 1 EV corresponds to 1.6 times 10 to negative 19 joules. So basically what you're doing here, you're multiplying 120 times 1.6 times 10 to negative 19, and you will get your answer of 1.92 times 10 to negative 17 joules. So with all the electrons, as they go through the voltage, the potential difference, 120 volts, that's how much energy is going to be provided by each of the electrons. So that's one thing you need to know in order to do this question. So basically the definition of electron volt. And then question number 10 says student design an experiment in order to measure the current through a resistor at different voltages given the following data. So this is actual sort of experiment or a lab you might actually end up doing in a classroom. Unfortunately, we didn't get to do it, but you can do it as an assignment. So the tricky part here for part A is to draw in the proper graph, because you can either graph this on your X, on your Y, or switch them around. Now you have to think about it for a moment before you start graphing. So think of Ohm's law. It says V equals IR. Now the question says we're looking for the R. So we're looking for resistance, which means you're going to solve this for R. So R is going to be V over I. So this is where you have to think about where's your V going to go, where's your I going to go. Well, slope is rise over run, which means your rise has to be your voltage and your run has to be your current. So this is going to be your current, and this is going to be your voltage. Okay, so if you flip them, you're not going to get the right answer. But if you get it right, then it's just a matter of setting the proper scale, graphing it, and then looking at the slopes. Remember, this is going to be your slope. So the slope of V over I is going to be the resistance. Now I did this already for part A. I used Excel. I plotted the 2 columns, so current and voltage, and I also added the trend line. So the slope here, as you can see, is 20.834, and that's what the answer says for part B. That's going to be your slope. They provided plus minus 0.5 ohm as the uncertainty there, which from the graph you would actually need to graph it by hand to get that. But 20.0, 20.8 in this case, that's good enough. So that's how you get the answer for part B. You had to actually graph it, and you had to graph it the proper way. So make sure you have your voltage on the y-axis and your current on the x-axis. And then plot the points, and you're going to graph the line of best fit, and then you had to figure out the slope of your line of best fit, and you should get somewhere close to 20. Right? So if you have any more questions, make sure you post them in comments on Teams.